Hello everybody. For the next couple of sections, we're going to be looking at how we do rotations around points. For 3.3a, we're going to be turning a figure around the origin as the center. And then when we shift over to the other half in 3.3b, we'll be looking at how we turn a figure around a point that's not the origin. But luckily, the two problems are very, very similar to each other. You'll find they use a lot of the same skills and a lot of the same math in them. So, since we are going to be taking a look at how this will actually go, we are looking at a rotation here, which if you look at the picture, we take this original triangle, ABC, and it is rotated to become this triangle, A prime, B prime, and C prime. Rotations are nothing more than a turn around some fixed point, and that fixed point is called the center of rotation. Every rotation has two components to it. You are going to have a specific degree measure, commonly 90, 180, or 270, and a direction, clockwise or counterclockwise. We have very simple rules for how points are transformed when we go to rotate them. So we'll start with the counterclockwise group that you see here in the table. If we turn a figure 90 degrees counterclockwise, every XY point in that figure is transformed into the opposite of Y, comma, X. So for the first one, let's go through the specifics, make sure you see the pattern, and then you'll have the idea of what the other two are telling you to do. We're going to take the two values of our coordinate point, X and Y. We are going to flip them, so the Y value first, the X value second, and we're going to change the sign of the Y value. So for example, if we had 1, 3, this rotation would create -3, 1. If we turn a figure 180 degrees counterclockwise, every XY point would be transformed into -x, -y. So the order stays the same, we just give the opposite of both of them. And if we go 270 degrees counterclockwise, every XY point gets transformed into y, -x. So again, like the 90 case, we'll flip them, but we'll take the opposite of the X value in this particular case. Definitely be thinking about how turns of certain degrees behave. 90 degrees counterclockwise would also be if we went 270 degrees clockwise. So if we went the other direction around the turn. 180 would be itself, whether we go clockwise or counterclockwise, wouldn't matter. But 270 counter would also be 90 degrees clockwise. So no matter which direction you're given, clockwise or counterclockwise, the rules behave the same. As far as problems go, ultimately the basic plan is to look at what are the points given in the figure, apply the transformation rule, and give your new answer. It's honestly that direct. So if we take a look at this triangle, ABC, that's drawn here, point A, if we go count the points in the graph, is 2 on X, and 1, 2, 3, 4, 5, 6, 7 up for Y. Point B is 1, 2, 3, 4, 5, 6 for X, and then up 1, 2, 3, 4, 5 for Y. Point C, 1, 2, 3, 4 for X, and then up 1 for Y. So our 3 points from that picture that's graphed are simply 2, 7, 6, 5, and 4, 1. That's really all we need the picture for. At that point, all we're looking at is, let's apply the rule. Since we're told in the question, 90 degrees counterclockwise, we'll pull this directly from our table. If you need to go back and review the table, 90 degrees counterclockwise turns everything into opposite of y, comma x. So when we come back down to this question, we'll simply fill in this part of it. So take every XY pair and turn it into opposite of Y, comma, X. So we're gonna flip-flop the numbers and make sure we take the opposite of the Y value. So we're gonna flip-flop 2, 7 into 7, 2, and we're gonna take the opposite, negative 7. We'll flip-flop B into 5, 6. We'll take negative of the second one, the negative of the Y value, and we'll flip-flop C into 1, 4. We'll take the negative of the 1, at which point, that's our answer. That really is all it takes to do each one of these. Come up with the coordinate points, and then go through and simply apply the rule based off of whatever rotation you've been asked to do. All right, so for the second example here, we've got 4 points of a square, PQRS. So same plan, we're gonna go through and just simply figure out what each one of them is. For point P, we have 2, and then 1, 2, 3, 4, 5, 6. We have 2, comma, 6. For Q, 1, 2, 3, 4, 5, 6, and then up 1, 2, 3, 4, 5. So that'll be 6, comma, 5. Point R, 1, 2, 3, 4, 5, and then up 1. So there's 5, comma, 1. And point S, 1 step to the right, 2 steps up, to be the point 1, comma, 2. We were given 180 degrees clockwise, and if you remember from the table portion right above, 180 degrees is the special one where it doesn't really matter if we go clockwise or counterclockwise, the result is the same either way. Every XY point is going to be transformed into opposite X, comma, opposite Y. So we're gonna keep the numbers in the exact order you see them, but we're gonna change them to opposites, which for this example is very elementary. Every single number is positive. You notice the whole square is in quadrant 1, so we're gonna end up rotating it to quadrant 3, turn them all negative. So we'll take negative 2, negative 6, negative 6, negative 5, negative 5, negative 1, and negative 1, negative 2 to be the answer. Where's our new square located? At those 4 points. The idea of every single one of them is just simply go through and apply the actual rotation formula. It's that simple. All right, so let's take a look at example 3 here. We are given this rhombus, CDEF. So let's go through and figure out its points first. So point C, 1, 2, 3, 4, 5, 6, 7 to the left, and 1 step up, so negative 7, comma 1. And then we're gonna take point D, that is 1, 2, 3, and then 1, 2, 3 up, so negative 3, positive 3. Point E, we come 1 step to the left, and then 1, 2, 3, 4, 5, 6, 7 up, so negative 1, comma 7. And then lastly, point F, 1, 2, 3, 4, 5 steps to the left, 1, 2, 3, 4, 5 steps up, so negative 5, comma 5. We are asked to rotate this 270 degrees counterclockwise. So we come back and look at the table again. 270 degrees counterclockwise turns everything into Y, comma, opposite of X. So every single point that we have is transformed into Y, comma, opposite X. So we need to flip the numbers around, and then for all the negatives that we had in the X coordinates, we're gonna have to take their opposites and make them positive. So 1, comma, positive 7, 3, comma, positive 3, 7, comma, positive 1, 5, comma, positive 5. And that'll be the values for our new location for our image. The last one here, same idea. We'll go through and fill out the coordinate points and then simply apply transformation formula. So point D, if we go counting, 1, 2, 3, 4 to the right, 1, 2, 3, 4, 5 up. So we've got a point that's at 4, 5. E, 1, 2, 3, 4, 5, 6, and then down 2, 6, negative 2. And then F, 1 step right, 2 steps down to place F at 1, negative 2. We're asked to give 90 degrees clockwise. So if we come back to our table, don't forget the table shows you counterclockwise in it. So you have to make sure to read the specialty note here. You are looking at the clockwise one. 90 degrees clockwise is this last transformation on the bottom. Everything is changed into y, negative x. So every point that we have is changed into y, opposite of x. So we're going to keep the y values and take them first, and then we're going to take the opposite of every x value. So we have 5, and we'll take the opposite, negative 4. We have negative 2, we'll take the opposite, negative 6. We have negative 2, we'll take the opposite, negative 1. For these coordinates to be where our image is after it's been rotated 90 degrees clockwise. That's everything for section 3.3a. You'll see in the next section and in the next video, we can do this same rotation step around points that are not the origin, which is very similar work, but is a little more involved. If you've got any questions on rotations around the origin, make sure to ask your teacher, and see everybody in the next video.